We all know shadows. We live with them all our lives. But how much do we really notice them? We know that it happens when an object blocks light coming from a source. Usually, it is the sun. So, we can take the example of this ball. What happens when light from the sun gets blocked from it? We have a 3D object projecting a 2D image onto a planar surface, such as the ground or a wall. Before we move on, let's get some vocabulary out of the way. Look at this shadow, the one created by this ball right here. We can see that it is mostly dark and a perfect circle. That is called the umbra. But if you look closer, you can see that the edges are a bit fuzzy. That is called the penumbra. We expect, assuming a perpendicular light source as the sun is right now near noon, we expect that a perfectly spherical object will create a perfectly circular projection. But this changes a bit when the shadow approaches another one. That is called the blister effect. Okay, what do you say about this? Okay, this could work. Tell me what you think about this idea. We check at what is the final distance at which the ball's umbra touches the tape, which is how we're going to define it, okay? Because here we can see it is at like this much distance, but if I put it on the wall, it's going to literally be on it, right? So that could actually be a measurable thing. Let's see here. Ooh, then here it's huge. Wow, that's actually huge. Because I think it is very hard to measure a small increase in. We could measure, okay, I'd say we do some trials. I thought we should make some tracks here. We can make a track, you know, so then the ball will be on the track. And then we can just move slightly the pasta and we can see where the pasta ends up. There. Looks good. And then we can just say boom. There. Yeah. So that's way more noticeable. And there it is touching. Perfect. Okay. Next step. Tracks. I guess I should just extend the red tape. And then this will be good enough. Or the other option is, you have an even thicker book than this one. You can make better tracks, put it here, and start making some measurements. Right now we're setting the 0 to match up with the umbra, which is marked by this red line. We will move the ball until the umbra of the ball reaches the marked tape. At that point, we will check with the fishing line where the ball hits, and then we will measure the distance. We'll do it for one close, middle. I mean ideally 5, but I think 4, because or else they will be so close together they won't be noticeable enough. Okay, should we start taking the data? Is basically that because we're also having the effect of that as the ball gets closer to the light source, its shadow enlarges. And because we have very little difference between position 1, 2, 3, and 4 in how much blister effect, not in how much blister effect, because it is very noticeable to the eye, but in how much the position of a ball is changing. I think maybe we can just put the ball, get the diameter of it, okay, before it is close to the book, and then we make it blister until the two umbras touch, and then we calculate like a new diameter, if you know what I mean. It's not going to be a diameter because it's no longer going to be a circle, it's going to be like this, it's going to have the bulge, but we calculate from the bulge to the other side, and that will give us essentially how much more distance it is covering. And I think that is way more noticeable when we measure that on the wall instead of on the little track we created. Okay, so we can see here the setup. We got the little flashlight here, and we have marked every spot with tape so that in case we need to redo anything, we can do that. So yes, we have object B, and we have the little tracks for the ball so that we can move it very slightly until we want the desired effect and the umbras barely touching. We also have marked spots at sort of regular intervals, so that we can have data points along the whole distance from the book to the wall. Something important is that since the blister effect is more noticeable within, let's say, this range, we have a higher density of data points here, because near the wall, as I can show really quickly, it's pretty insignificant. Yeah, it's pretty insignificant, so it doesn't make too much sense to have a lot of data points here when the real effect we want to measure is over there. I really enjoyed doing this project. I mean, I really like that it started from something so simple that I noticed naturally. It was just a shadow, and one day I had the ball and it got close to another shadow and I realized there was something weird going on. And I sometimes think, how could I not notice that for all my life? And it is those tiny little things that happen in the every day-to-day basis that I think are super mystical and wonderful about physics. And about the project more in itself, I thought I learned a lot about being more flexible, having free range with the ideas, but also being limited in the resources. It is a lot about what is the best you can do with what you have. How can you get creative to make a measurement more precise? How flexible can you be in the approach you have to the experiment? I personally had a certain idea when we started, but then it got changed continuously. And you have to learn to adapt, and I think that is very great. So I'm happy. I'm really happy how things turned out.